Hello, in this section 12.4 we're going to learn the cross product. So this is also product between two vectors. So let's take a look at definition firstly. What's the definition of cross product? So cross product actually for given two vectors, and they are all non-zero vectors. So if they are not perpendicular, not parallel, sorry. We select a unit vector n perpendicular to the plane by right-hand rule. Unit vector means the length is 1, right? And the perpendicular to the plane and this plane is made by u and v, created by u and v, perpendicular to the plane by right-hand rule. So I'm going to show you what's the meaning of the cross product. Okay, so it's say for the cross product we do u cross v. U cross v. So it's different from dot, right? So what's the meaning? Here if we have u vector and we have v vector, okay, right-hand rule means we start from u vector, use your right hand, and point to v vector, and your sum, goes to like an n vector. So it's kind of like u v vector make a plane, and there is a unit vector n that's perpendicular to u v vector. Actually, u cross v equals what? It's a vector perpendicular to both u vector and the v vector. So u v vector is perpendicular to the plane made by u v vector. So what's the meaning of right-hand rule? Meaning of right-hand rule, for example, if we have this, now we switch the order of u and v, so you can see, okay, and the u cross v becomes what? Right-hand rule, right hand. So we start from u vector and point to v vector, turn your hand, and then your sum goes to the other direction. Okay, so this is u cross v, something like that. Let's take a look at the calculation definition. So u cross v is given by this way: u vector, u length, v length, sine theta times n vector. So you can see here the whole thing here is scalar. But what is an unit vector? That is like a direction, right? Direction. So direction perpendicular to the plane. This is a vector. Scalar times a vector is still vector. So we also call this vector product. U cross v is a vector. So it's also called a vector product. Okay, so that's the definition for the vector cross product. And what is n? What's the direction? Right-hand rule. So n, right-hand rule. Okay. Next, we're going to learn how to calculate the cross product, how to find the vector. And before that, we want to learn what is determinant, how to calculate the determinant. So let's take a look at definition 2, determinant of order 2. Actually, determinant is for the matrix. So here, matrix is list some array of numbers. So you can see A, B, C, D. This is a 2 by 2 matrix actually, and the determinant we write this way, determinant. And the calculation of a determinant by using this formula, A times D minus B times C. So AD minus BC. For example, if we say here we have two vectors, or we have a matrix, 2, 1, negative 6, 4 was determinant. So it's going to be 2 times 4 minus negative 6 times 1. So it should be 8 plus 6, which is 40. Okay, and you can try this one. 1, 2, 3, 4, just for any example. So it should be 1 times 4, 4 minus 6, which is negative 2. This is called the determinant of order 2. Next, let's take a look at the determinant of order 3. That is the determinant of matrix of 3 by 3. So here we have 3 by 3 matrix. We write down them as A1, A2, A3. 3 by 3 means 3 rows, 3 columns. B1, B2, B3, C1, C2, C3. So this 3 by 3, right? Now how to calculate the determinant of this one? So we are going to do this way. A1 times, this is A1 times the determinant, like a 2 determinant of order 2. If we cross the first row, first column, it's kind of like this way. Cross the first row, first column, and what left? B2, B3, C2, C3. Okay. And next, minus A2. So A2 times what? Determinant of order 2. If we cross the row and the column with A2, so which is, you can see B1, B3, C1, C3 left. And then last term is A3. And here A3, we cross, here's A3, right? Here is A3. We cross the row and column with A3, and this 2 by 2 matrix left. So B1, B2, C1, C2. So this is calculation of the 3 by 3 determinant. And just be careful, this term is negative. Okay, it's negative. And the A1, A2, the sign, they are all positive. Only the sign in front of A2 is negative. Now let's take a look at the example. We have 3 by 3 matrix. 1, 2, negative 1, 3, 0, 1, negative 5, 4, 2. And A1 is 1, right? And A2, so in front A2 is minus. And plus A3, so but A3 is negative 1. Okay, so we can write down plus A3 like this. Okay, and then let's see what's the 2 by 2 determinant. So 1 times this one, right? If we cross the first row, first column, 0, 0, 1, 4, 2 left. If we look at 2, we'll cross that one, 3, 1, negative 5, 2. Okay. And if we look at negative 1, for the negative 1, it is 3, 0, negative 5, 4. Okay, let's do the calculation. 0 minus 4, so it should be negative 4. And then minus 2, so here 6 minus negative 5. 6 add 5, 11. And then minus, so here 12 minus 0, which is 12, so minus 12. Negative 4 minus 22 minus 12, so it should be negative 26 minus 12. Final answer is negative 38. Now let's try another one. So 1, 2, 3, 0, negative 1, 1, 5, 1, 2. Okay, so first step, just set up the two determinant, other two determinants. So it should be 1 times negative 1, 1, 1, 2. This one, okay, and then minus 2 times 0, 1, 5, 2, and then plus 3 times that one. 0, negative 1, 5, 1. When you do this, be really careful. Okay, very easy to make mistake. Negative 2 minus 1, so negative 3. 0 minus 5, negative 5. 0 minus negative 5, so 0 plus 5. Should be this one, so should plus 15, yeah, and this becomes 7 add 15, 22. So this is the calculation of determinant of 3 by 3. Next, let's see how to calculate the cross product. So it's given by definition 4. Suppose we have two vectors. The u vector is given by u1, v1, u1, u2, u3, 3 components, or sometimes it's written down u1i, u2j, u3k form, right? Different form, but it all means vectors. Now let's see. And then we have another vector, which is v1, v2, v3. Okay. And what's the cross product of them? Because it's going to be determinant of other 3 by 3 matrix. So how to set up the 3 by 3 matrix? We put the first row as I, J, K. Do you remember what I, J, K are? They are just like units vectors. So U cross V, so second row will be U vector. So be careful, the order, we cannot switch the order. So the second row will be U1, U2, U3. And the third row will be V1, V2, V3. And just calculate this one, the determinant. So I'm going to show you how to do this in the example. Find U cross V and V cross U if the U vector is given by, okay, and the V vector. Let's take a look. Firstly, U cross V equals what? Set up the determinant. The first row, I, J, K. The second row is U vector. So U vector should be 2, 1, 1. Right? So if we look at the components, 2, 1, 1. And the V vector should be negative 4, 3, 1. Let's do the calculation. Then A1, which is I, times that, minus J times determinant of order 2, plus K times determinant of order 2. So now let's take a look. I times what? It's 1, 1, 3, 1. Okay, for the K, that is 2, 1, K, 2, 1, negative 4, 3. For the J, just cross that one. So should be 2, 1, negative 4, 1. Let's calculate the two determinant of order 2. So the first one should be 1 minus 3, so negative 2 times I. So I put a constant in front because this is I times negative 2, right? So we like to write down negative 2I in this order. And minus, so here 2 minus negative 4, so should be 2 plus 4, 6, 6j. And for the case component, let's see, 2 times 3, 6, 6 minus negative 4, so should be 10, 10k. So this is U cross V. Now let's calculate V cross U. V cross U, we do IJK. Okay, and right now V is in front, so we have to put a V as the second row in the second row position. So V is negative 4, 3, 1. U is 2, 1, 1. So let's calculate this one. Minus J plus K. For the I's position, 3, 1, 1, 1. For the J's component, negative 4, 1, 2, 1. For the K's component, negative 4, 3, 2, 1. And calculate this one. 3 minus 1, 2, 2I. For the J should be negative 6 and negative in front, plus 6J. For the K, negative 4 minus 6, so it should be negative 10. Okay, and then right now, if you look at U cross V and V cross U, you can find some relationship. U cross V is exactly negative of V cross U. Is that right? So for the cross product, we cannot switch the order. So please remember, we can say this. U cross V does not equal to V cross U. So for the dot product, we can switch the order and they are totally same. But for the cross product, they are not same. Okay, U cross V is different from V cross U. What's the difference? They are opposite in the opposite direction. The reason why, if you can look, here is U cross V, right-hand rule. So where's our n direction? Here, right? If you look at V cross U, so your right hand should go to U first, V first, and go to the V. So this is like a U cross V direction. And okay, let me just write down U cross V direction. U cross V direction, because our right hand rule, we use our right hand, start from U and go to V, and the sum point to U cross V, right? The other way, V cross U. V cross U. Right hand point, start from V vector and point to go to the U vector, and our sum goes to this direction. So this is V cross U. So you can see those two vectors, just a totally opposite direction. Okay. So that's the calculation of the cross product. Now let's just do one exercise. Find U cross V. If I ask you to find a V cross U, you don't have to do the determinant again. You just take the negative of U cross V. That's okay. For U equals 2I minus 2J minus K. V vector is I minus K. I will give you the solution later and you can check. So here is the solution for U cross V. And for the V cross U, if you want, we know they are just in the opposite direction, you just make all the components into negative. So negative 2i minus j minus 2k. So that is v cross u. Okay, so here we can stop here, and next class we are going to do the applications and what's the meaning of real meaning of the cross product and how to use this to do some other problems.